In this last lecture, we're going to talk about the different ways that absorption can be carried out. So with batch absorption, you're going to do it in some kind of tube or flask or some kind of container. And you're going to mix the feed solution and the absorbent particles. You can mix them by stirring or vortex or anything like that. And the two are going to come in contact until an equilibrium binding is achieved and your target molecules bind to that absorbent. So here, that's this first step here. You just mix the two together in the tube, probably vortex it or shake it up to get contact between the target molecules and the absorbent. Then you have to have some way to remove that liquid containing all the molecules that didn't bind to the absorbent. So you have to separate the solid absorbent from the liquid, usually by filtration or centrifugation or some way like that. The spent solution, remember in extraction, we call that the raffinate. So you get rid of that liquid, you throw it away. Then you're going to go through a wash step where you add a solution or some kind of wash buffer to the absorbent, go through the same process, maybe vortex it or shake it up good to wash away any impurities that might still be associated with the absorbent but not actually bound to it. Then you go through the same process of separating that liquid from the solid, so maybe centrifugation again, remove that wash buffer that might contain impurities. Then you can get to the step of elution. So then you have to add some kind of elution buffer that is going to favor desorption. So it's going to be unfavorable conditions for binding of the target molecule to the absorbent. And then again, you're going to mix it up really good and then go through that separation process again, centrifugation. And this time when you remove the liquid, your target molecule should be in that liquid. So it's going to be separated from the absorbent particles, and then now you have your purified target molecule. So that's batch absorption. Now, an alternative to that is something called packed bed absorption. And this is where we're going to start getting into that column chromatography. And we're going to talk about this a lot more in the next chapter. But in this chapter, it just kind of refers to it as some kind of cylindrical object that you pack your adsorbent in. And so here, like when we talk about column chromatography, we usually refer to the adsorbent as a resin. And we usually refer to it as a stationary phase because it doesn't move. It stays, within this cylindrical column. And then what you do is you're going to add your feed solution, which usually in column chromatography we call that the mobile phase. We're going to add that feed solution to the column, and then either by pump action or by gravity, that liquid is going to flow through the adsorbent, and in the process of the mobile phase moving through the stationary phase, any target molecules that are present in that feed solution will bind to the adsorbent in the stationary phase. So what comes out in the initial binding steps, what comes out, which is called the eluate, and that process, the process of removing the target molecule is called elution. But whatever comes out can be collected. So the process goes, what's great about this process is the stream of adding the mobile phase through the stationary phase. You can go through those steps of equilibration, binding, washing, and eluting without having to do these centrifugation or filtration steps that you have to do in batch absorption, where you have to separate the stationary, the adsorbent from the liquid. This removes that requirement, so it saves time. All right, so the process is cyclic in nature, meaning you have to go through these steps. So the first step is the absorption step, where you pump the feed solution into the packed bed to load the molecules. The washing step, you add some kind of buffer to wash to make sure you remove all molecules from that adsorbent packed bed that aren't just like hanging out there in the void space. That you want to make sure that you get rid of anything that's not actually bound to the adsorbent. And then the third step is elution, where you're going to add a buffer solution that's going to be unfavorable for binding of the target molecule to the adsorbent. So the target molecule is going to be released, and then it will pass through the column and elute from the column. And then you can collect it, and then now you have your purified target molecule. So you can also, the nice thing about this is through the process, whatever's coming out of that column can be monitored by UV or some other method to see what's coming out of the column when. And we're going to talk about that a lot more in the next chapter. So some other absorption devices have been created based on a need due to some of the problems associated with packed beds. So some of the problems, there's a lot of cost that goes into pumping that mobile phase through the column. If you have any kind of particulates in the feed solution, that can be problematic with this method. The flow rates themselves have to be pretty low, and you have radial dispersion, which is an issue. So all these issues have led researchers to come up with different methods for absorption. Fluidized beds are one example, and expanded bed absorbers are another. So in these cases, what happens is the absorbent, instead of being packed down into a column, it's actually kind of loosely packed within some kind of container with a lot of space on top. And the feed solution is actually pumped in the column from the bottom, which allows fluidization of the absorbent bed. So it's kind of like a mix between the batch absorption, where you vortex and mix the solution, and the packed bed, where it just travels through the stationary phase. You kind of get the advantages of both. You still don't have to, you can allow gravity and whatnot to separate the liquid from the adsorbent, but without, so you don't have to do like the centrifugation or filtration steps that you do with batch absorption, but it also deals with some of these issues that are associated with the packed bed. Now, membrane absorbers are another method used. The best example I can think of right off the top of my head for a membrane absorber, if you've ever done purified plasmids from, nucleic acid plasmids from a cell culture, you usually have these little kits that have these little columns that have a little filter in them, and you bind your DNA to the filter and you wash it through several times, and then you eventually elute it. But you're using this little membrane filter as the adsorbent. So this is an example of that. And we'll talk about this more, though, when we get to, I believe this is the last chapter that we'll cover this semester, which is the membrane-based separations. Okay, so that is it for this chapter. Make sure you read the chapter, go through the lectures, go through the PowerPoints, review all the material, and you'll be ready to take the quiz this week.